Um, okay, and we'll just go to next page. So I've prepared a few questions for indices. Even though I know you sort of both good students and you sort of done the indices, I just want to sort of to show a few ways how to set up your work and how sort of to do it in a quicker way. So I've picked up a few questions that are sort of a bit complicated. Not really, but yeah, sort of means you have to think a little bit. So look at that question. So first, you can simplify expression in the first bracket. I always like to work with numbers first, and I can see that 12 and 3 can be cancelled. So they're both divisible by 3. So that's the first thing I do. I cancel 12 and 3, and so that will be 4, and that will be 1. So on the next line, that will be 4. Okay, good. Now, the next thing that I would look at, I'll look at, you have 8 to the power of 6 at the top and 8 to the power of -1 at the bottom. So on the side, I'll just simplify that. Okay. So the positive index stays on the top, the expression with positive index stays at the top, and the expression with the negative index can be actually brought to the top. Okay, so when we take the expression with the negative index and bring it to the top, we'll just have 8 to the power 1. And there's nothing left at the bottom, so it's just 1. And then you simplify 8 to the power 6 times 8 to the power 1. That gives us 8 to the power 7. Okay, so 8 to the power 6, the same as 8 times by itself 6 times. 8 to the power 1 is just 8 times by itself once. So overall we have 8 times by itself 7 times. Or we just follow the rules where we have to add indices. Right, so 8 to the power 7. And we have b to the power 2 and 1 at the bottom. Okay, done. The second fraction, you only have one number 4. At the top you have 8 to the power 0, which is just equals 1. So that's just times 1. Any number to the power of 0 equals 1. Okay, so that's interesting fact, like say you have 100 to the power of 0, it gives you 1. You have 1000 to the power of 0, it gives you 1. And you could have, say, -50 to the power of 0, that still gives you 1. Okay, so just remember, any power to the power of 0 equals 1. That's why we can simplify that. Okay, so now we have b to the power of -3 at the top and b to the power of 6 at the bottom. So that can be simplified. You can just take b to the power of -3 and bring it down, which will become b to the power of 3 in the denominator. And then you multiply b to the power of 6 and b to the power of 3 in the denominator. Alright, I'll just write it on the side so you have a bit more clear idea. Just need a bit of space. Alright, now let's do it. So we have b to the power of -3 over b to the power of 6. So we leave b to the power of 6 in the denominator because the index is positive, and b to the power of -3 will bring down, and when we bring the expression with negative index to the other side of the fraction, the index becomes positive. Okay, so that becomes equals 1 over, we add indices, 6 plus 3 gives us 9. So we have at the bottom b to the power of 9. Now, with negative index of a, you have a to the power of -4 in the denominator. You just bring this expression up and it will become positive. So in the numerator, we will have a to the power of 4. Excellent. All right, next step. So let's have a look at numbers first. 4 times 4, so you get 16 at the top. And then we have 8 to the power of 7 times 8 to the power of 4 at the top. So that would give us 8 to the power of 11, 7 plus 4. In denominator we have b to the power of 9, and at the top we have b to the power of 2. So I'll just write it down. So you have, sorry, my writing needs to be moved a little bit. Oh, sorry. Sorry, I just wrote a bit too close, and it's just, let's be. Okay, we'll do it again a bit lower. So that's 16. That's a to the power of 11. And now we have b to the power of 2 at the top and b to the power of 9 in the denominator. Okay, so notice at the top that means b times b twice. At the bottom you have b times itself 9 times. So if you write it on the side, you could think of that like this, b times b, and at the bottom you have b times b times b, and so on 9 times b. Okay, so notice that 2 of these can be cancelled. Alright, so what you will end up with? You will end up 16 a to the power of 11, and then you'd have b to the power of 7 in the denominator. Okay. The other way you could do it, you could do like this, b to the power of 2 over b to the power of 9. It's a division, so it's b to the power of 2 take away 9, which is the same as b to the power of negative 7. And then b to the power of negative 7 is the same as 1 over b to the power of 7. So that's why we could have write this 16 a to the power of 11 b to the power of negative 7, but that would be the same as 16a to the power of 11 times over b to the power of 7. Okay, now if you have any questions, just click on the second symbol on the left and choose any symbol you have there. There's a few, you can choose the sun or whatever, and point out where something you don't understand and then talk through it. Do you have any questions? Like, do you understand all the steps? You can type your answer or you can say your answer. Okay. Okay, excellent. Shana, what about Michaela? Okay, not at the moment. So could you ask me where you sort of struggle, which part of that you struggled? I can go through it a bit slower. Maybe I was a bit fast. Can you point out where you struggle? Or you're fine with all of that? I'm not sure what you mean by not at the moment. If you understand everything, instead of typing just next to your name, you can click on the smile face, and that's about it. That's all you have to do. You have a few symbols there. Okay, all right. Okay, that's fine. So we'll do a few more questions, and you can always look at the recording. Okay, let's have a look at the next question. That's where we have fractional indices. All right. So notice that that index 1/3 applies to every expression in the brackets. So it's 1 to the power 1/3. In the denominator, a to the power of 2 to the power of 1/3, b to the power of 0 to the power 1/3. Okay, good. So let's do that. So we have, okay, 1 to the power 1/3. I'll just do it on the side. 1 to the power 1/3. It's the same as just cubic root of 1. So what number do we multiply by itself 3 times to get 1? It's 1. Okay, that's good. So that's 1. Now in the denominator we have a to the power of 2, and then we have to take it to the power 1/3. So that would be a to the power 2 times 1/3, which is the same as a to the power of 2/3. Okay, so twice, double a third, so you have 2/3. Or you could have think like this, 2/1 times 1/3 would be equal to 2/3. Okay. I actually like when students see that when you have a number and you multiply it by a fraction, all you have to do, you have to multiply the numerator of that fraction by a number. So it's just 2/3. Okay, so you have 2/3 as an index of a. Okay, b to the power of 0 is 1. So remember, any number to the power of 0 equals 1. So 1 to the power 1/3 gives you 1 again. So that's it. You don't need to write times 1. Times, you have 3, a to the power of 4, b to the power of -6. Okay, now let's put it all into the fraction. So again, we have a fraction and we multiply it by that expression. So we can multiply just the numerator of that fraction, which is 1, by that expression. So we can put it into the numerator. The other way to look at it, if you're not quite clear on that, you can put this over 1. And then you just multiply numerators and denominators. So that would be 3, a to the power of 4, b to the power of -6, over a to the power of 2/3. Okay, equals, now 3 stays, a to the power of 4, take away 2/3, we subtract into 6, and b to the power of -6. Okay, I just need a bit of space, so I'll just delete the stuff on the right. Okay, so let's continue. Equals, so we'll just go there. Equals, so you have 3, 4 take away 2/3. 4 is made, so 1 take away 2/3, it's 1/3, so it will be, okay, a to the power of, and then b to the power of -6, so we can put it in the denominator. Now let's work out, what is 4 take away 2/3? Okay, we know that 1 take away 2/3 equals 1/3. Okay, and so the answer would be 3 and 1/3. But in an index, it's better not to have a mixed number. So what you could do is you could have do 4 take away 2/3 equals 3. And so 4 times 3 is 12 minus 2/3. So that gives you 10 over 3. So this either way is fine, but see how you could write your answer. You could have just put 10 over 3, but it still looks a bit awkward. And usually this answer is written like this. 3 over b to the power of 6. Notice you could use 3 and 1/3. So it will be a to the power of 3 and a to the power 1/3. Okay, and a to the power 1/3 you could write as the cubic root of a. Okay, so the final answer could be written in a few different forms, but usually it's written like this: a to the power of 3 and cubic root of a and b to the power of 6. Okay, questions? Just let me know how did you go. The next question I'll ask you to do. Okay, do you have any questions? Okay, I'll just go through this quickly. Okay, alright, good. So just go through this quickly. So first of all, 1/3 applied to every value of that. So it's 1 to the power 1/3, which is 1. A to the power of 2 to the power 1/3 becomes a to the power of 2/3, and b to the power of 0 is 1. Then the second expression, we put over 1 denominator, and we multiply numerators and denominators. So you have 3 a to the power 4, b to the power of -6 at the top. Should separate this because it's a bit awkward. Okay, and you have a to the power of 2/3 times 1, that's it, and that's at the bottom. Okay, let's I'm not used to write on that screen very well. I have to space it a bit. Okay, good. So now all we do, e to the power of 4, take away 2/3. 4 take away 2/3, it's 3 1/3. So the answer becomes a to the power of 3 times a to the power of 1/3. We can write them separately because 3 1/3. And then b to the power of -6 in the top becomes just b to the power of 6 in the denominator. And so this is the final answer. Okay. Now let's have a look at next slide. Right. Okay. Now, what I'd like you to do, I'll give you a bit of space. And so I'll divide the page in 2 parts. And so now, Michaela, you can use the left-hand side. And Shana, you can use the right-hand side. And you could just work on the screen and try and tell me what would you do to solve this question. Okay. So try to simplify this expression, then simplify that expression, then think what you do instead of division, and so on. Okay, would you like to do it on the screen? Just click on the pen symbol and use the screen space and do it. Okay, so Mikhail on the left and Shan on the right. That looks like it's a highlighter. Okay, that's good. You need to get used to this pen tool. And I guess it's a bit difficult to write with mouse. You can, if you click on A, you can type, but I can scaffold it for you. I can do like lines. So I can do like line, and the same here. I'll just delete that. Sorry. I'll just do line here and line here, and there is division in between. Okay. Alright. Okay, so Michaela, use the left-hand side and Shana, use the right-hand side. Okay, 15, a to the power 5, that's good. So you brought a to the power -5 to the top and it became a to the power 5. Didn't quite understand how did you get 15. You have 5 at the top and 15 at the bottom. Okay, that's good, that's better. 5 and 15 can get cancelled. So you'd have cancelled, they're both divisible by 5. 5 divided by 5 gives you 1, and 15 divided by 5 gives you 3. Okay, so 1/3 is good. A to the power of 2, b to the power of 2, that's good, we just copied. Okay. Oops, sorry, okay. Okay, try again, Shana. Okay, I can see what you're doing here. You have a squared, b squared. What happened to this a to the power of -5? What happened to that? Oh, you've got this a to the power of 7. Good, alright, that's good. And now here 10, a to the power of 2, b to the power of 9. Okay, how did you get 9? Think carefully. You have -3 there and 6 there. So there's 2 ways. You can take -3 and bring it to the denominator, or you subtract indices. -3 take away 6. What will that be? -3 take away 6. What that would be? Shana, keep going. Don't look at what Mikhail is doing. Try to keep going yourself. I can see you've done 1/3. Keep going. I'm not sure, you're confused. Okay, have a look at these. A squared, b squared, and a to the power of -5 at the denominator. Keep the expressions with positive indexes at the top, And the expression with negative index, instead of having it in denominator, bring it up. And then the index -5 will become +5. So let's now help you. Okay, you're doing it. Good. Okay. So a to the power of 2. Okay. And a to the power of 5 gives you 7 and b squared. Good. Okay, and there you have 10. A to the power of 6 over a to the power of 4 gives you a to the power of 6 take over 4, which is squared. And b to the power of -3 and b to the power of 6. What would you do with that? Just b? B to the power of 9. Excellent. Okay, so that's very good. So when you have b to the power of -3 over b to the power of 6, all you have to do, keep the expression with positive index in the denominator, and the expression with negative index you can bring the denominator. And you're right, that would be equal b to the power of 9. Okay, excellent. Right, that's all good. Now we have division. So copy the first expression, change the sign to multiplication, and flip. The second expression has to be flipped upside down. Okay. Okay, so b to the good. Okay. Excellent. Okay, that's great. All right, so that's all you do. Okay, fantastic. And now what we can do now, we can multiply numerators and multiply denominators. Look at the numbers first. You have 3 there. There's no numbers here. There's no numbers there, and 10 there. So just multiply 3 and 10 in denominator. Then look where you have terms with A and terms with B, and simplify them as well. Okay, that's good. Keep going. You can use just one line now. Okay, this just can be just one line. B to the power 11 over 3 A. Okay, so you have, just be careful, there's a to the power of 7 at the top, is it? Yeah. And a to the power of 2 at the bottom. So they can be simplified. Okay. So you have a to the power of 7 and a to the power of 2. So what that would be? A to the power of 5, good. That's good. B to the power of 11, that's good. And in the denominator you just have a number, which is 30. Okay, excellent. Alright, that's very good. Okay, well done. And we can move to the next page. Okay. Alright, here we have expression with fractional indices. So I'll just go through this question. Look, you have 2 to the power of half. Notice that this is 9. And we know that 9 can be represented as 3 squared. Okay, so 9 equals 3 squared. Okay, so instead of having 9 to the power of half, we can write 3 squared to the power of half. And why it's good? Because now we have to multiply these indices, and 2 times half gives us 1. So it's the same as 3 to the power of 2 times half, which gives us 3 to the power of 1, which is just 3. So that expression at the top gives us just 3. Okay? So that just gives us 3. Okay. Now, next bit. And I'd like you to help me with that. 27 and 1/3. Okay. How would you express 27 so that you could simplify that expression? 27. what do you think it equals to? You can write on the screen. Just take your pen, write on the screen. Mikhail, you can write it. Okay, 3 to cubic 3 of 9, cubic 3 of okay. Okay, so that's correct. Notice that that is the same as 3 to the power of 3 and to the power of 1/3. But whatever you did before, you're right. So 27 to, so there's two ways to do it. So you could have written 3 cubed, and then you could say 27 to the power of 1/3. Oh, sorry. Sorry, I just meant something else. Okay. So 3 to the power of 3, and then if you take it to the power 1/3, 3 times 1/3 is 1, so that would be equal to 3. The other way to do it, you're right, you could have used the square root. Sorry, I'll just have to take this off. Okay, you could have said that 27 to the power of 3rd is the same as cubic root of 27. And I've seen you've done that before. Okay? And so you think, what number do you multiply 3 times to get 27? Oh, that's 3. Okay? So this is 3 as well. Okay. Times. And now the most difficult one is the last one. It's 18 to the power of 2/3. So 18 to the power of 2/3. Oops, sorry. It's 2/3. Okay, so you could have break it up. You could have said it's 18 to the power of 2, and then to the power of 1/3. You could do that. Or you could say it's 18 to the power of 1/3, and then to the power of 2. Whatever is easier. You have to think what would be the best approach. The other thing we have to note is that 18 equals to 2 times 9. And we know that 9 is 3 squared. Okay. So that's another thing that you can notice. Alright? So we have base 3 there and base 3 there, but this is just 3 times 3, so that's just cancel out. So really all we have here is 1 over 18 to the power of 2/3 left. So if we simplify that expression, we'll basically be able to find the answer. Okay? So I can't see that if I take any of this number to the power of 1/3, I can't see that that would be simplified, because there is no cubic root of 2 as exact value and no cubic root of 9 an exact value. So I think I'll follow this approach first and see if that would be helpful. Okay, let's try that. Okay, now let's try that. So 18 squared is the same as 18 is the same as 2 times 9. So that would be 2 squared times 9 squared. Okay, because instead of 18 we could write 2 times 9 and then squared and then to the power 1/3. Okay, so and then we still have to take it to the power 1/3. Okay, so that equals 2 squared times 9 is 3 squared, so 3 squared and then squared would be 3 to the power 4 and to the power 1/3. Okay, so that would be 2 squared, 3 cubed, and times 3, and to the power 1/3. Okay, so now look, why did I do that? Because I can see that 3 cubed times to the power 1/3 would be just 3. Okay, so you would have 2 still to the power of 2/3, 3 times 3, and times 3 to the power of 1/3. So really, that's all you can do. So the answer would be 1 over, and that expression goes there. So the answer would be 1 over 2 to the power of 2/3, which you could have write as a, or let's put 3 at the front. So that number 3 goes first. And then you have cubic root. So you could have write cubic root of 2 squared times 3. So that would be equal 1 over 3 and cubic root of 12. That's all really you can do. Okay? So this one is cubic root of 2 squared, and that one is cubic root of 3. So you can put them together. Okay? Alright, that's fine. Okay? So it's a bit awkward, like the answer is not that simple, but really that's all we can do in this situation. Okay? But still, if you look at the initial question, and so you can see that the final answer is much more simpler. Okay? The other way to write it, you could have put in the denominator 4 to the power 1 or 12 to the power 1/3. Alright? Okay. Any questions on that, or can I move to the next question? Mikhaila has a smiley face. What about Shana? Okay, excellent. All right, now let's move to the next question, and I'll ask probably you to do it. Okay. All right, fractional indices. So again, I'll divide the side in 2 parts, and Mikhaila, you can work on the left, and Shana, you can work on the right. Okay. Before doing anything, look here, 4. This is like square root. Okay, 8. Okay, think that's 8 is 2 cubed, and so on. 16, that is what? Think of what like these numbers of their sort of factors. 16 is the same as 4 times 4, and which is would be 2 to the power 4. So the other thing that I suggest, it is important to know that like 2 squared equals 4. Then 2 cubed equals 8, and so on. 2 to the power 4 equals 16. 2 to the power 5 equals 32. So it is important to remember these numbers so you can recognize them easily. The same as for the powers of 3 and powers of 5. So 3 to the power 1 is 3. Oh, sorry, let's start with 2. It's 9. 3 to the power 3 equals 27. Sorry, I took your space, Shana. I'll just finish in a minute. 3 to the power 4 equals 27 times 3 is 81. So it's important that you recognize these numbers. That would help you to simplify expressions. Like clearly you can see here, that is the same as this one. So that's 2 to the power 4. This 4, that's 2 squared. This is 8, so that is 2 to the power 3. So I advise you like to remember these numbers. Okay. Now let's delete. Okay. Now I'd like you to do this question. Try to simplify one expression at a time and see how you go. Okay, very good. Shana, you can work on the left. Try not to look at what Mikhaila is doing. Try to work on your own. And I'll help both of you. Just take a new color and just try to do it. You can type if it's easier for you to type. Click on A symbol and type if it's easier. Oh, Shanna, okay. We lost you and you came back. Sorry, sometimes it just gets disconnected. Okay, you're almost done there. Look here. So 4 to the power of half, it's square root of 4, which is 2. That's good. Now divide by 16. So you put it in denominator, and cubic root of 16 is 2. That's right, because 2 to the power of 4 is 16. Oh, sorry, fourth root of 16 is 2, because 2 to the power of 4 is 16. So that's 2, and you cancel 2. So that's good. So the only expression you have left is this one. And you realize that 8 is 2 to the power of 2. Oh, sorry, 2 to the power of 3. And so that becomes 2 to the power of 9 over 4. How would we simplify that? Let's have a look. So we have 2 to the power of 9 over 4. Okay, so that is the same as 4th root of 2 to the power of 9. Okay, so notice that that is the same as 4th root of 2 to the power of 4 times 2 to the power of 4 and times 2. Because 4 plus 4 plus 1 gives you 9. Okay, so we basically break this up as 2 to the power 4, 2 to the power 4, and 2. And why I do that? Because I know 4th root of 2 to the power 4 is 2. 4th root of 2 to the power 4 is 2. So the answer will be equals 2 times 2 and 4th root of 2. So that equals 4 times 4th root of 2. Or you can write it as 4 times 2 to the power of quarter. Okay, times. Okay, but I prefer that answer. Okay, I don't like answer with a fractional index, but sometimes they ask you to give answer with a fractional index. Okay, so really it's a very simple question. It just looks awkward. And I liked how Michaela, instead of writing in this form, you put instead of that a fraction symbol and you put that expression denominator. That's a good practice. Okay. Alright, let's do the next question. I think you'll follow me. Oops, I want to go where I wanted to go. Oh, sorry, just give me a second. Here we are. Okay. Look at this question before you do anything. Notice the same base, x. Alright? So I suggest express each expression with fractional index, and at the top you can add indices, and then you can subtract indices. Okay? So you can't really work with because this is a square root, this is cubic root, this is 6th root. So if they would be all square roots, it would be easy to do. Like say if you had, say, square root of 3 times square root of x over square root of 7. You could have just write it all under one square root. 3 times x, which is 3x, over 7. But in this situation, the root, this is square root, this is cubic root, and this is 6th root. So they're all different. Therefore, each of them, first of all, you have to write with the fractional index. Okay, I'll give you space. And again, Michaela, you can work on the left, and Shana, you can work on the right. Okay. Right, so I'll give you the fraction line. Write each expression in with the fractional index. So instead of x square root of x, you can write x to what power? Okay. Half. Okay. I'll just we need to clean it up a bit. Okay, try again, Michaela. So we'll just put x times x, and I'll put x here, and you can just write the fractional indices. X times x and x. Can you write just the indices? Okay. So that's half. Good. What about this one, the next one? Okay, that's 2 over 3. Good. So the root symbol gives you the denominator. That's good. Okay. Yeah, that's good, Shana. Well done. Okay. Okay, and 1/6. Excellent. Okay. Now what I'd like you to do, add the indices at the top. Okay, just add these 2 indices. And the same here. Okay, so what will it be? There's the fraction line. The fraction line. Okay. Sorry, this line is a bit awkward. I'll just do it again. Okay. So at the top we have to add indices. You have half and 2/3. So what I suggest, just work on the side and think, what is half times 2/3? So have half, and notice you do have exam without calculator at the end of the year. One exam with calculator, one without, so you should be able to add simple fractions. So how do we add fractions? Okay. Sean, is the same for you. What is half plus 2/3? Plus. Okay. So what do we do? What would be the common denominator of 2 and 3? Okay. I can see, Michaela, what you're doing. Keep going. That's right. Half is 3 over 6. And 2/3 is 4 over 6. Good. I can see, Shana, that you realize that the common denominator is 6. Okay. That's very good. So it's 7 over 6. Excellent. Okay. So we have x to the power 7 over 6 at the top, and x to the power 1/6 in the denominator. So all you have to do now, 7/6 take away 1/6. Which is very simple because these fractions have the same denominator. Okay, I'll just rewrite the denominator for you to help you. I have this special pen which just sort of makes it easier to write than to do it with the mouse. Okay. Okay, and you can just write the final answer. Okay, so 7/6 take away 1/6. 7 over 6 take away 1 over 6. What that would be? That's right, 6 over 6, which makes the same as just 1. So the answer is x. Alright, so this is our final answer. Okay, because 7 over 6 take away 1 over 6 equals to 7 take away 1, and that equals to 1. Okay, very good. Alright, let's move to the next question. And I think you're doing very well. Okay, your turn again. And I try not to help you too much. If anybody would like to talk, click on microphone symbol and maybe just talk through the question before you do anything and tell me, what do you notice? Okay, Mikhail or Shana, if anybody would like to talk, just tell me what you notice before you do anything. What could be simplified just by looking at that question? You can click on the second symbol in Tools, which is like has a hand, and then you will be able to point out on the screen. Then click on microphone symbol so we could hear you. Okay. Brackets and the root. Good. Okay. So we have brackets here and the root there. Okay, this one. That one simplifies easily. But make sure half applies to 2 and half applies to a squared. Okay? So make sure when you use half, you apply it to 2 and you apply it to a squared. Okay? So you raise 2 to the power of half and you raise a to the squared to the power of half. The same at the top. You raise square root of 2 to the power of 3, a to the power of 3, and b to the power of 2/3 to the power of 3. Okay? Now let's work on the screen. Let's simplify the top and simplify the bottom part. And again, Michaela, you can work on the left, and Shani, you can work on the right. I'll help you a little bit. Okay, I can put 2 for you. I can put A, and I can put B, and you can just write the indices. I'll put 2, I'll put A, 2, A, B, and you can just write the indices to make it a bit simpler. Okay, so what would be the indices? 2 to, okay, that's good. A to the power of 3, B to the power, okay, careful, you have 2/3 times 3. Okay, what that should be? 2/3 times 3. 2 to the power 1/3. That's half here. That's not 9/3. 2 times 3. Okay, a to the power of 3, b squared. That's good. Now keep going with the denominator. I'll just helping you, Michaela. I'm just cleaning the space for you. Okay. 2 to the power of half. You can see what Sean is doing. That's good. And a to the power 1. Fantastic. I'm impressed. And here, careful, it's not third. You have half here. Okay. Good. Right, I'll just do it for you. I can see you've done it. Half and a to the power 1. Okay, excellent. So next step, let's simplify it. Okay. So notice here you have 2 to the power of 3 over 2 and 2 to the power of half. So it's division. So subtract indices. 3 over 2 take away half. What that would be? I'll put 2, A, B, A, B, and you can just do the indices. Okay, and what will be in the denominator? Keep going, Michaela. Just keep going. So we have a to the power of 3 there and a to the power 1 there. So what will be the index here? 2. And b, still the same. There's no other expression. Okay, that's right. There's a 1 in denominator. Why is it a question mark? Okay, there's nothing left there. So that's disappears, so it's just 1. And when we have 1, we don't need to write the denominator. So our answer will be just that. That will be our answer. The denominator 1, so we can leave it out. Because when we divide by 1, expression stays the same. Okay? Just clean the denominator. And this is our answer. Alright, fantastic, girls. I hope you enjoy working on the screen. Okay, another one for you. Okay, and I'll help you just with writing because my pen is a bit more flexible. So you have x times x, and you can write the indices. X times x. Okay, and now put brackets first. So simplify inside the brackets first. Think what index will be inside the bracket and leave 1/3. Okay, that's good. Alright, so instead of having, okay, the 2 gives you the denominator, so 3 over 2. Now 3 gives you the denominator. Okay, x to the power 4, and then that gives you denominator 4/3. Good. Okay, next step. So we keep the first part the same, 3/2, and the second part becomes x to the power 4/9. That's very good. Okay, keep going, Mikhail, very good. When we multiply, what do we do with indices? We add them, so it's 3/2 plus 4/9. I advise you to work it out on the side. Okay, work it out at the bottom. What is 3/2 plus 4/9? Because when we multiply two expressions with the same base, we add the indices. So we don't multiply indices, we add them up. Okay, that's very good, Shana. And I suggest, just on the side, work out what is 3/2 plus 4/9. Okay, equals. And the same for Michaela, 3/2 plus 4/9. What does it equal to? Okay, you should know how to add fractions. Think, what is the common denominator? So 18. Okay, so 3 times 9 is 27, plus 4 times 2. 4 times 2, 8. So 27 plus 8 gives us 35/18. Okay, yeah, that sounds like good. Looks like good. And you can change it to a mixed number. 18 plus 18 is 36. So it's 1 and 18. And what will be the numerator? Okay, the mixed number. What is the numerator? What will be here? Okay, 17/18. Okay, good. So there's two ways you could write your answer. You could have write as x to the power of 35/18, or you could write it as x times x to the power of 17/18. Okay, there's two ways to write it. I probably would go for x to the power of 35/18. Okay, just to make it simpler. Alright, so there's two ways to do it. Oh, fantastic. Okay, let's move on. Next slide. Now we're coming to matrices. Okay. Don't know how well you went with matrices. I've just got to talk through it a little bit. This is a summary of transformations with matrices. So, the matrix in this form produces dilation of k in the x direction. So you can see you have k, the factor here of dilation. Here you have the factor of dilation in y direction. Then that's a reflection in x-axis, that's a reflection in y-axis, and so on. Okay. And sometimes it's difficult to remember. That's why I usually advise students to have this summary on their cheat sheet. So let's see how we could use that to do the question. We have a point with coordinates -2 and 6, and it's transformed by a dilation of 3/2, which is 1.5, in the x direction, and then reflected in the line y equals x, and then dilated of 2 in the y direction. And I'll do this first part of the question, and then I'll ask you to do the second part of the question. Okay, let's do it. So, point -2, 6. So you can put it like this: x coordinate first and y coordinate second. It's transformed by dilation of 1.5. Okay, and in the x direction. Alright, so we have a look. So it's in the x direction, so we have to use this matrix. Instead of k, we'll have 1.5. So what we'll do, we'll just write 1.5 here, and then we have 1, 1, and 0. and we multiply these two matrices. Okay, it's good. Just double check before we move on. So dilation 1.5 in the x direction. So dilation by k in the x direction. So instead of k, we have 1.5. Okay, now how do we multiply the matrices? So we take, I'll just use another column. We take the first row and we multiply it by that. Okay, so we have 1.5 times negative 2, that gives us negative 3. And 1 times 6 gives us 6. So negative 3 plus 6 gives us negative 3 plus 6 gives us negative 3. Okay, I should choose another color, sorry. Negative 3. Okay, good. And now you take the second line and multiply by the same column. So 0, the second line, 0 times negative 2 gives you 0, and 1 times 6 gives you 6. So the second term is 6. And so that's the answer. I really didn't have to do this line, otherwise it looks like fraction. Oh, can't delete it now. Okay, I'll just move that. Okay, good. Alright, so this is the answer. Okay, so we've done the first transformation. So what we do now, we take our answer, negative 3 and 6. Let's check what happened here on the plane. So we had negative 2, 6. So the point was somewhere there, negative 2, 6, and became point negative 3 and still 6. Okay, so all that happened, the point was moved to the left. Okay, so instead of negative 2, you have negative 3. Okay, so that's all that happened. So 1.5 times negative 2 gives you negative 3. So the point was moved to the left. But it's supposed to be moved by 1.5. Have we done any mistake? Negative 2, negative 6. Okay, it's a bit strange. 1.5 times negative 2 gives us negative 3, and 1 times 6 gives us 6. Okay, so I did make a mistake. Okay, so let's fix mistakes. This will be plus 3, is it? Plus 3. Or did I make another mistake? Let's check. 1.5 times negative 2, that gives us negative 3, plus 6, it's plus 3. Okay, so if you look at that point on the so that has the original point, and 3 and 6. So it was negative 2, 6, now 3 and 6. There's a point moved here. So that's not right. So I answer, that's what means that the point would move by 5, not by 3.2. Oh, sorry. Dilation, it's not translation. I'm confused myself. Sorry, girls, if I've confused you too. Okay, it's a dilation, it's not translation. Okay, so you're multiplying the, so the point was at a distance of 2 from the, at a distance of 2, okay. The point was at a distance of 2 from x-axis and was dilated by 3 over 2. So now the point is at a distance 3 from x-axis. Okay, so So the total distance is -5. So -2 times 3/2 gives you 3. Okay, that's right. So that's all good. All right. Did I do something wrong? I can see you're writing something there. Book. What's book? Mistake in a book. Oh, that's right. Oh, thank you. Oh, I'm thinking something is not working here. Okay, I'm getting tired by the end of the lesson. Sorry. Thank you very much. Oh, you're such a great help. I'm impressed. I'm thinking it's not working. Something is strange. Okay, thank you very much. Yes, there was a mistake in the book. That's supposed to be 0. Okay, thank you. Okay, so that's 0. All right, now let's do this question again. So I will just change. Okay, so that has to be 0. I'll put it in the pink color so we can see where was the mistake. So that was supposed to be 0. Okay, well, let's do it now. Hopefully it won't take us too long. I'm supposed to go home. Okay, so 1.5 times -2 gives you -3. And the next line is 6. Okay, that's good. Right, so now what happened to x coordinate was -3. It was -2, then it's multiplied by 3/2, it becomes -3. Okay, very good. Right, so next step, we have this point -3, 6. Okay. Alright. And we have what we have to do, reflect in the line y equals x. So that's what we have to do, this part. Deflect in the line y equals x. So we have to multiply by the -1, 0, 0, 1. Okay, it's good. And so that would be -1 times -3 is 3 plus 0. And 0 times -3, we take the second line and multiply by the column. So 0 times -3 is 0, and 1 times 6 is 6. Good. Okay, so see what would happen if you look at the original point was -3, 6. It was there, was reflected in this line, and the coordinates between 3 and 6. So as if you have a mirror in the middle, and the point was reflected. Okay, and the last step, we have to do dilate by factor of 2 in the y direction. Okay, so you take this your answer, 3, 6, and then by a factor of 2 in the y direction, so we have to do this one. It's a dilation. Again, so the matrix is 1, 0, 0, and instead of k, we would have 2. Okay, and again, when you multiply fractions, okay, you take the first row and multiply by column. So 1 times 3 gives you 1 times 3 gives you 3, and 0 times 6 is 0, so it becomes 3 plus 0. 0 times 3 is 3, and now you take the second line. 0 times 3 gives you 0. 0 times 3 gives you 0, and 2 times 6 gives you 12. But the answer is 12. Okay, so the answer is 312. Okay, I actually have the answers. Let's check if we've done it right. Okay, so the answer is 6 and minus 6. Well, did we do something wrong? And we got 3 and 12. That's interesting. So we've got the 12, but for some reason it shouldn't be 3. It should be 6. Oh, that's interesting. I can't really see any mistake. I'm just quickly going through. This one. Oh, this was... Okay, let's see. So that's delta of 2 in y direction. Delta of 2. Did I miss -1 here? That has to be -1. If it was -1, then it would be -3 there. But it still doesn't make 6, isn't it? Oh no, sorry. No, that's not right. Sorry. Sorry, no, that's plus, because all we did is this one, right? We did not reflection, we did dilation, so we had to do this one. Okay, so 1, 2, no, we did everything right, it was plus. I'm confused, maybe the answer is wrong. Okay, don't worry too much. I think we've done all the steps right. I'll check the answer, I'll double check the answer and email it to you. The other question was, would we get the same answer if the transformations were appeared in reverse order? Okay, so that's actually good practice. So what you do, you take the point and first you dilate it by a factor of 2 in y direction, then you deflect it in the line y equals x, and then you dilate it by a factor of 3/2 in x direction. Okay? If you do this exercise, you'll notice that the answers will be different. So when you multiply numbers, it doesn't matter in what order you do it. But when you actually multiply fractions, it does matter in what order you're doing. Okay? Okay. Mikhail, I can see your question, so I didn't see you before. It's asking if addition is the same as translation. When we translate fraction, yes, we add things. Okay, see here, matrix A B produces a translation of A in X direction, B in the Y direction. So say, for example, you had a matrix say for example you had a matrix of say 2, 3, 4, 1. I'll just do the simple number. Say for example you had a number 2, 3, and you translate that number 2, 4, and you say translate this number to the right by 5 units. Okay? So what would you do? It's a translation parallel to the x-axis. Okay, so it's a horizontal translation. So what would you do? You would plus 5 in x direction and 0 in y direction. So the new number would be 7, 4. Okay, so y value stays the same, but the x value would change. Okay, if you have to move that number up, you would take 7/4, and say you have to move it up by 3 points. Then the x value would stay the same, so you add 0, but y value you add 3. And so you would have 7, 7. Okay. Notice that this could be done at one step. You just put 5, that's translation to the right, and 3 the translation up. And so you would have 2/4, and that would just give you 7/7. Okay? That's why the rule is like that. Okay. Okay. All right. Now, what I emailed you this PowerPoint. So what I suggest, just for practice, you can do. Okay, we have to fix here. Just before you start to work with that PowerPoint, we have to fix a mistake here that we've noticed. Yeah, so that has to be 0. Okay, not 1. Okay, and so when you work, try to repeat this question, and then try to do the next step when you do the same translation in opposite order. Okay, and then you'll notice that the answer will be difficult. And you have answers at the end, so you can use that. But I suspect that that answer is incorrect, so I'll try to sort of go through this question again, and I'll email you the solutions. Okay, I took it from the book. I'm not sure. Maybe there's a mistake. Right? Do you have any questions before we finish the lesson? You can talk. Shana left the room. Oh, okay, Shana's back. Okay, all good. All right, thank you for joining the lesson, girls. I hope it was helpful for you. Next time, if you want me to go through any questions or concepts, just let me know, all right? So that I know where you have difficulty today. I just sort of looked at week 1 and I sort of thought, oh, these are difficult parts, and I sort of use these questions. And Mikhaila, do you want to say anything or type something? Just give me some feedback. Was it useful for you? Was it a bit slow? Was it okay? You can type on the screen if it... Okay, excellent. I'm glad that was helpful to you, Mikhaila. All right, girls, just have a nice weekend, and I'll see you next week on Friday.